go over some of the frequent mistakes that I witnessed you guys made in your homework and in the quiz that was held in the class. So I know it's quite some time after that, and a lot of you probably practice to certain extent, and probably are much better. But I think it still would be helpful to go over some of the mm, like mistakes that probably will again happen during the exams. So let's go. Let's say let's. So one of the first mistakes that you can make is not to actually draw the free body diagram, because there is a good chance, again there are chances that you make a mistake along your way, and you really want to give um, as much as possible for the grader to give you points. And one of the things that you can actually use for that purpose is to draw the free body diagram. Not only that, it will help you to minimize the possibilities of making mistakes in writing your equation of motion. So please draw it. It will help you. It help your final score definitely. So with that out of the way, another very frequent and I should say fatal mistakes that I've seen many of you made was, so basically we have an equation of motions like in its final form. Oh, that is too. Let me just that. Okay, so basically we have for mass number one, mx1 double dot. Let's say we don't have a damping gear and we have only k1 to x, right? Or maybe you have k1 plus k2 to x equals 0. So two mistakes here you can make for writing the M or K matrix. One is that you take this side and put it over, so to the other side, and so you write M x double dot equals minus K1 plus K2 x, right? So this is still showing the force equation for your mass, and but if you take this and try to get the stiffness matrix from this form of this equation, then you will have something like this. So which is actually equals minus k, but then you would take this as a k, and then it will ruin everything up after that. So everything, your eigenvalues would be wrong, your mode shapes, everything would fall apart pretty quickly. So please do not do this. And also, even in this initial form, some of you divide everything to m. So you write x double dot equal plus, I don't know, k1 plus k2 for the first mass divided by mx equals 0. And then what you get is your mass matrix would look like this, and then your stiffness matrix is basically like this, equals m1 and m2, right? So this is also would cause problems. Okay, so the entire idea, the whole idea of calculating a k tilde thing and calculating a mass normalized stiffness matrix is to basically do this. But since these are matrices, you cannot just simply divide by m and then having the same thing. So please avoid this. Only and only use this form. So you have a stiffness thing here, stiffness term, and you have a mass term, and then try to use that to actually calculate the mass and the stiffness matrices. Okay, so if you do this correct, I think the foundation for any of the problems or questions that you will face in your exam will be solid, and you'll do okay on that, on those questions. So that's the first part. It's a little bit messy here, so forgive me for that. Another thing is, let's see, the calculating of m to the power of minus half. So this thing has a lot of use cases in our calculations. A lot of times, if you want to calculate this thing, or if you want to calculate this thing, you will need to you need this thing here, m. So I've seen people multiply the values in the matrix, a mass matrix, by minus or by half, instead of like getting a square root. So it's simple. For anything like you have a mass matrix like this, you just put every these values to the power of minus 1/2. So it will be it would get into this and 1/√3. Simple as that. You don't need to do all those like getting the inverse of the matrix and stuff. It's just simple for these kind of matrices which have like values only on the main diagonal, the diagonal matrices. That's all you need to do. Don't do anything. You don't need to do anything else. So but I've seen a lot of students actually made this mistake, and it also, the thing with these problems is that you make any mistake in the beginning, everything after that would go down pretty quickly. So pay attention to this thing if you did not previously. So okay, let's go to another thing that is worthy of mention. Is a lot of this is like a basic, like a cheap mistake to make. Missing the negative signs or miscalculations. It really sometimes, like I've seen, like for example, you want to get a mode shape, right? And you have a something like this, like a u11 minus b u12, and suddenly you get u11 over u22. You get a positive value for that somehow. So you did not pay attention, or just forgot, or sometimes in calculation of the square root, you might forget a sign, confuse it with a positive and negative, or sometimes forgot an entire thing. So pay a lot of attention to these calculations, because I know it's tedious, and these problems have a lot of these kind of calculations that, like, it's like a minefield, and you can make a mistake anywhere. But just if doing it more slowly will help you, by all means do that. But be careful not to do any kind of these kind of mistakes. It's really not the things that you want to lose point on. Yeah, so I've covered this thing. There's no drawing for it. Oh, another thing. A lot of the times I've seen you calculate the natural frequencies and it is a negative value, which is just wrong. Your natural frequencies cannot be negative. If you get a negative natural frequency, you have done something seriously wrong beforehand. Okay, so if you get something like that, sometimes I've even seen like people got negative signs under the square root. Look, guys, we are not dealing with complex numbers here. If you see complex numbers, I think only in this formulation, when you are trying to calculate the mode shape and the eigenvalues, and you say, okay, x equals u e power r w theta or something like this, is the only time that it kind of goes near those areas, but we don't really deal with any of the complex number at this point. Okay, so if you get a complex number for your natural frequencies, please check again. And yeah, a negative under root square. Oh no, we don't want that as well. Uh, and also something, it's not like a very big deal, but I've seen. I think it's good to have it in mind. So let's say you're calculating the natural frequencies or the eigenvalues, and you have two eigenvalues. Like one is like 3, one is like 1/3, right? So pay attention. The smaller value is the first eigenvalue, and the larger value is the second eigenvalue. So actually, your eigenvalues in a matrix thing is always should be something like this. Two eigenvalues probably should not be the same, so I'm not sure about this part, but yeah, it generally should be something like this. Depends on the size of your matrix, of course, but yeah, so keep this in mind as well. It would it probably will save you some points at some point. Okay. Natural identity, mode shapes, and eigenvector structure check. Not sure I'm going to do this one. So I've covered that. Oh, another very frequent mistake is to confuse these two terms. So sometimes we have this thing when you have this equals 0. Sometimes we have this thing. So this is V. Forgive my not very good handwriting here. So I can see how this can be confusing, but bear with me here. So both of these forms give you the same eigenvalues. So if you try to calculate the eigenvalues, you can go for both of them same lambda and same omega n. So if the question asks you to calculate you will definitely need to calculate the natural frequencies. So you can go use both of these forms. It would give you the same results for natural frequencies, but it is very possible that you will need to calculate either mode shape, or you will be asked to calculate the eigenvectors. So these two are not the same thing. For mode shape, you will need this form. So you will put the natural frequency here, and you have your stiffness matrix, you have your mass matrix, and then you have this u vector like this, and yeah, you basically need to calculate the ratio of u11 over u12, and that gives you mode shapes. And later on, or maybe I can do it here, you don't need to normalize the mode shapes, right? It's just a ratio, right? Um, for eigenvectors, however, this is not like you cannot calculate eigenvectors beam here. You need to calculate the eigenvectors from this equation, which you will need to do this mass normalized stiffness matrix first, and then you can use the same if you've previously used this to calculate the natural frequency. You can put the lambda straight on here, and then you do the same thing that you did for the mode shapes, and then I calculate the eigenvectors. It's the same. It's just here you need to do the mass normalized matrix, and then use this form, and then you get the eigenvectors. But pay attention, usually you will need eigenvectors to calculate p, and in your p matrix, which is first eigenvector and second eigenvector. So both of these are eigenvectors, like it would be like ab and probably minus ab or something like that, or probably minus like this, something in this order. So this will be your first eigenvector, this would be your second eigenvector, and pay attention, these eigenvectors should be 100% normalized. If it's not normalized in your future calculations, when you want to calculate your this this thing, I don't know what it's called, or you want to calculate this, oh sorry, for if you want to calculate the S matrix, which is useful to transform between the physical and model systems, you will need this P matrix. And in that thing, you definitely want to have normalized eigenvectors, not the not normalized eigenvectors, should say. So also that is another thing to pay attention on. Pay attention to the okay. So I've covered the two forms of eigenvector and mode shapes. Okay, I covered this. This one remains. One thing I can also mention here is, usually when you have a system like this, right? Let's say we have a mass here, m1, we have another stiffness, and we have a mass 2. This can also have a dash plot in between, doesn't matter that much. So what happens here is, either these two masses can go with each other, like they can move like this, like they go like this, or they can go opposite to each other, right? Like the natural frequencies that they can have, like this one goes here, this one goes here. So knowing this, we should expect that our mode shapes should not be like AB and then CD, because both of them have positive ratios. In similar systems, what we expect to get from the mode shapes is something like, let's just AB and then I don't know, minus C to D, right? So if you're calculating and then you were asked to get the mode shapes, or I don't know, maybe get the system response, and you are calculating the mode shapes, and it's basically the same logic for eigenvectors is also true. You should get something like this because you have two natural modes, which are one is like two masses go in the same direction at the same time, and then the other one that the masses are moving opposite of each other. So if it's not something like this, it doesn't have the same this kind of structure, you probably made some mistake. So it's probably a good idea to double check your calculations, if especially see if you calculate the eigenvalue or the natural frequency correct, because that's probably the main thing that can mess it up. Or you made some mistake in this part when you didn't pay attention to the signs and solving the equations to get the ratio and eventually calculating the mode shapes. So it's also this is also a good tip for preventing some unnecessary point loss during your exams. And I think one other thing remains. Um, what shipping with structure check? Okay, so another tip that I wanted to give you is, so you calculate the system response, like the physical system response, and you get some equation. For example, you get, I don't know, maybe 2 minus cosine 2t, I don't know, plus p over 6, something like this, maybe. And then you get 1 plus sine 4t, right? For a 2-degree of freedom system. And then you have some boundary conditions, right? If you get this response, this is your final answer, please just put the t equals 0 and check if you get the correct values. It's a very simple thing to do, but it if you made some mistakes somewhere, a lot of the times it can show itself in this step, right? Otherwise, it's not like 100% shows you any mistake you can make, but a lot of the mistakes can actually show up in your final answer, right like this. So it's also a good thing to do, not only in this course, in general, in any other course that you're required to get calculation or put boundary conditions or initial conditions to get to an equation. If you get the final equation, just if you have time, just put in the initial values to see if your equation gives the actual initial conditions or initial values that you're given for that equation. So yeah, so these are the major mistakes that I've seen through the homeworks and the quiz, the first quiz that I've graded so far. The other thing is, from the later on content lectures, there's one point that I think you can use, is that at some point you will calculate the C tilde, which has two values like this, okay? And just bear in mind that these two values are these values. So alpha here is 2 times omega 1, because it's the first row, and then on zeta 1, which zeta is, of course you know that, I never can write this thing correctly. Just assume this is the thing, but we don't know what it is. It's the C1 to the critical C, which is, I think, I don't remember the value correctly. It's like 2, I think it's something like this. It's something like this, right? Or it's equals to omega n times m. Okay. So yeah, just keep this in mind, and also be very careful around calculating this S matrix, which is very, very useful in transferring between the physical realm and the model like area. So it is very useful because you want to calculate the system. You have something in the physical, you want to go into the model, and vice versa. So if you make a mistake in this S thing here, you'll probably have a hard time after that. So pay extra attention to this thing, and be sure to calculate it correctly, and then after that you should be also fine. So you will know that S equals m to the power of -1, right? Let me just want to be sure about this, not to give you any incorrect thing. So S here. Okay. Yeah. So it's this, and S minus is, so you switch these places and then get a negative, but negative P is P transpose, so it's like this. These are super important. So yeah, extra attention on these as well. So most of your attention first should be on these, calculating the M and K correctly, and also pay attention to this because a lot of mistakes have been made in this part. And also, I think this would be a major source of mistake in the exam. So please pay attention to this part. And I think if you do everything that I said correctly, and just follow the steps, and make sure the math is right. You did not make any like the cheap mistakes, and I'm sure you will get a great score for this upcoming exam. So I hope this was somehow helpful. If you have any questions or something, just give me a message. Send me a message in the web courses, and I will answer to the extent of my power as quickly as possible. I hope you will have a great exam tomorrow, and probably see you all in the next one. Bye, guys.